The first step in the scientific method is when we observe and start to theorize and hypothesize about what might be true. This is the foundation for much of research because much research is about testing hypotheses. In this section, we're going to answer a few questions. First, what is previous research? Second, what is the role of previous research to current research? And third, how do theories, research questions, and hypotheses relate to each other? Research is conducted to increase our understanding of phenomena and to specifically test our hypotheses. Before research can be conducted, we start by making observations and theorizing. We can and should also consult any previous research that can help us understand the phenomenon of interest. It is necessary to know what research has been done so that you can refine your ideas before you start conducting your own research. Not only can this prevent you from spending time and effort needlessly on something that is already very well established, but it can also help you think of your own observations in new ways and give you ideas about methods, their benefits, limitations, and what's needed in the field. Once we have made observations and begun theorizing, we must move towards creating research questions and subsequently hypotheses. A research question is a general question that develops from our observations, theories, and from reading existing research. Hypotheses are more specific statements about what we expect the answer to the research question to be. Hypotheses should be testable and are questions or statements that, when tested empirically, can be supported or refuted. Hypotheses are also often directional. That means we state whether we think things will increase or decrease during the study or whether two things tend to increase or decrease together if we're doing correlational work. Let's take a look at some examples of this. Research question 1 asks, is sexual health education related to sexual risk behavior? Notice that this is a pretty open question and it doesn't make any predictions about direction. Now look at the corresponding hypothesis. It states, students who receive comprehensive sexual health classes will be more likely to use sexual protection compared to students who do not receive these classes. There are a few things to notice here. First, the hypothesis is very specific. The hypothesis begins to define what we mean by things like sexual health education and behavior. When we begin to define things so that we can define how we will measure them, we are operationalizing our variable. A variable is anything that we set out to measure in a study. We are beginning to operationalize here, but we will talk about this in more detail later and how to go about measuring things once you've come up with your operational definition. For now, notice that sexual health education is specifically stated as a comprehensive sexual health class in the hypothesis. Also notice that sexual risk behavior is defined as using protection in the hypothesis. Finally, notice the wording. It says more likely. Here, the hypothesis is directional. A directional hypothesis states the specific kind of result we expect, such as increase opposed to decrease, improved health as opposed to poorer health, or lower scores as opposed to higher scores. The research question is not directional. It simply asks if education is related to behavior, but it doesn't specify whether classes are expected to relate to more or less risk. Pause the slide and look at research question 2, taking notice of the differences between the research question and the hypothesis. Try to assess what the variables are and whether a direction is posited in the hypothesis. The two variables are sleep and cognitive functioning. Hours of sleep are what are being used here as what seems to be the theoretical independent variable, and scores on a memory test seem to be the theoretical dependent variable. We also have a directional statement here, because hypothesis 2 reads, hours of sleep will be positively correlated to scores on a memory test. Notice the research question simply asks, is sleep related to cognitive functioning? But the hypothesis goes further to provide what the expected answer will be. It specifies the two variables and gives us a direction. After a hypothesis has been formed, we have to design a study that will provide us evidence that can either support or refute that hypothesis. We then must collect and analyze the data so we can draw a conclusion as to whether our hypothesis held. Our hypothesis should include our prediction as to what will happen. This is reflected in the directional nature of well-developed hypotheses. The results of your research can support your hypothesis in theory, but in the behavioral sciences we very rarely use the word proven. We are tentative in drawing hard lines for a number of reasons, some of which you should already be familiar with from your statistics class. Here, I'll just name a few of the important points. First, a hypothesis is a narrow slice of a larger idea. Theories are broader than research questions, and both theories and research questions are broader than hypotheses. Therefore, when our hypothesis is supported with evidence, it means only a small part of the question has been answered, and thus only a small part of the overarching theory has been tested and supported. Second, our results are limited to how we have defined what we are studying. This goes back to the concept I mentioned a moment ago called operationalizing. In example 1 on the previous slide, the researcher was interested in sexual health education, but narrowly defined this as comprehensive sexual health classes in the hypothesis. We might have different results if we were looking at health outcomes for those who had abstinence-only sexual health classes or any other form of sexual health education. Third, our results are limited to the sample we used. This is part of a concept called generalizing you'll learn more about later when we talk about validity and reliability. For now, we need to keep in mind that when we collect data from people, those data and the subsequent results are most applicable to those who are similar to the sample from which the data were drawn. For example, if I gather data only from teenagers, my results will be most applicable to other teenagers and may not be applicable to children or adults. Thus, if I collect data only from college student adults, those data are most applicable to adults who are in college and may not apply to adults who are not in college or who have never attended college. You will likely discuss this in your statistics class when discussing the use of samples to understand populations. Fourth, sometimes, just due to chance, our results are not an accurate representation of the phenomenon. When this happens, our data will either evince support for the hypothesis when in fact the hypothesis is wrong, or our data will evince refutation of the hypothesis when in fact the hypothesis was correct. That is, sometimes the data say our prediction was right when in fact it was wrong. This is called a type 1 error. And other times the data will say our prediction is right when in fact it was wrong. This is called a type 2 error. Let's take a moment to refresh our memories from statistics to help us understand this fourth issue. When we gather data from samples in the hopes of understanding populations, we want to do so randomly. We also want our data to represent the population well. That means that people in our sample have to have or should have the same characteristics as those in the population we hope to understand, and the sample needs to behave in ways that are similar to the ways the population behaves. That is, when we wish to make inferences about a population based on a sample of cases, the sample should represent the population well. As you'll recall, we then assess the result and the significance of the result. You might also recall that significance roughly means the level of confidence we have that if we carried out the same study again, it would yield the same results. Each time we use inferential statistics, we take some risk that even if the sample is randomly generated, that it will not represent the population, and therefore they will get a result that doesn't represent what is true of the population. When we looked at significance in statistics, which is also called the p-value, we were assessing whether the risk of having an erroneous conclusion was greater than 5%. If the risk was lower than 5%, we typically considered the result to be significant. However, this means that each time we are 95% sure, there's still up to a 5% chance that the sample results do not match what is true of the population. So essentially, we're accepting the risk that we will be wrong 1 out of 20 times. Because we cannot know if the current test is the 1 out of the 20 where this might occur, we cannot say without a doubt that our hypothesis is correct. If I said my hypothesis was proven, that would mean that I'm saying I am certain that the results will always be the same, that I am sure that if I do my study over and over and over again, I'll keep getting the same result. However, this is not the case with the vast majority of research in psychology and other behavioral and social sciences. For all of these reasons, we use the more tentative term support in reference to our hypothesis rather than the term proven. At this point, it should be clear why we refer to our hypotheses as supported or refuted, so let's get back to the steps of conducting research. Regardless of our findings, we will have cause to do additional research and must remain open to refining our theories and retesting our hypotheses. If my hypothesis is supported, it is supported for the sample collected, under the conditions tested, and based on how we defined each variable in that study. Thus, if I want to speak more broadly about my results, I'll need to test the hypothesis more broadly. If I only studied teens, but I believe my theory is accurate for adults, I need to retest with adults. We also often retest to help ensure that the first time we tested the hypothesis was not just that one chance out of 20 that we would get the result simply due to chance. In addition, we will learn that each research method or study design has its own strengths and weaknesses. Therefore, we can vary the method we use study to study to increase the overall strengths of research when we look across the studies and overcome the weaknesses of each study through the strengths of the others. This goes back to the idea of aggregation that I've mentioned in an earlier video lecture. Hypotheses are connected to theories, and when they are supported, that means aspects of the theory are being supported. A theory is a framework of understanding that consists of a body of ideas about a topic or phenomenon. As noted, it is much broader than the questions and hypotheses and subsumes them. The connection between theories and findings are bidirectional. The theory guides our observations, our research questions, and our hypotheses, and then organizes and synthesizes ideas and research findings. In that way, findings are going back to help us affirm or modify aspects of the theory. In the behavioral sciences, we often collect data from people or animals. You will hear various terms used to refer to people or animals who provide data or about whom data have been collected. The terms human subjects, and participants refer to people who are studied or who provide data for research. Subjects has the connotation that the individual did not choose to participate or was subjected to something that they were not aware of or about which they may not have been fully informed. This might sound a little sinister, but it's more in reference to the fact that the researcher always knows more about what's going to happen or what the hypotheses are than do the subjects. We will talk about the history of research and ethical issues later in a separate video. At that time, we'll discuss how important it is for researchers to be careful that they do not harm subjects or mislead them needlessly. Some researchers prefer to keep the ethical violations committed by previous research in the front of their minds by always referring to people in studies as subjects, because the term reminds us that we have the power in the research situation, and thus we have the responsibility to vigilantly monitor our own work to ensure the well-being of individuals. It's also acceptable and often appropriate to use the term participants to refer to those who are included in research. The term participant can be used anytime the individual is aware of the research and chose to take part in it. You may also hear the term informed participant. This means that the individual was formally told details about the aim of the study, the procedures, risks, and benefits before she or he agreed to participate. The term subject is much broader and can be used in reference to those who would also be considered informed participants. But when we say participant, it cannot be used for those who are uninformed. However, if an individual is not able to be fully informed or may not have the autonomy to choose not to be involved in research, the individual must always be referred to as a subject and not a participant. Animals and children, therefore, are considered subjects. In the case of children, it is the parent who is informed and chooses to allow the child to be included in research, and therefore, the child is not considered an informed participant, even if she or he has been told about the research beforehand. This is because we hold the belief that animals and children do not necessarily have the same cognitive ability as adult human beings, and thus do not fully understand even if the aspects of the research are explained to them. Take a moment here to refine your notes by answering the following questions. How are hypotheses and research questions distinct? Where does a researcher go to get ideas for research or to refine their knowledge about a topic? Why is this step so important? How are hypotheses and theories connected? How are the results from testing a hypothesis important to the underlying theories? What is the difference between a participant and a subject?